stop doing these 10 things. It's slowly killing your engine. Ask yourself, when was the last time you thought, my oil can probably go another 1,000 miles? That single thought is the deadliest habit in modern car ownership. While your engine is firing off 100 million times an hour, that good enough oil is failing, letting critical anti-wear additives burn off and allowing varnish to form on your pistons. This is the secret mechanics know but rarely explain. You are being lulled into a false sense of security. Watch this video to the end, where I'll expose the 10 things you are doing that are slowly killing your engine from the inside out. Number 10. Over-revving or constant redline. Driving that tachometer needle sweeping toward the red zone feels exciting, doesn't it? The rush of acceleration, the engine singing at high RPM. Many drivers believe occasional redlining clears carbon deposits and keeps their engine healthy. It's what performance cars were built for, right? Wrong. What you're actually doing is creating massive inertial forces that are tearing at your engine's most critical components. Every time your pistons reverse direction at top and bottom dead center, they experience forces several times that of gravity. At redline, these forces multiply exponentially. Those rod bearings, thin shells of soft metal designed to create a microscopic oil film between your connecting rods and crankshaft, are being hammered mercilessly. The oil film struggles to maintain separation between metal surfaces at these extreme speeds. Your valve springs are compressing and expanding so rapidly they begin to harmonically resonate, a phenomenon called valve float that destroys precision valve timing. What feels like performance driving is actually accelerated wear on components that cost thousands to replace when they fail. Modern engines might be designed to handle occasional high RPM operation, but making it a habit is like running a marathon every day. Eventual breakdown is guaranteed. Next time you're tempted to hold that gear just to hear the engine scream, remember what's happening inside those cylinder walls. Your wallet will thank you later. And if you think redlining is bad, wait until you see what happens when your engine can't breathe properly. Number 9. Ignoring small vacuum or boost leaks. That faint hissing sound when your engine is running. The one you've convinced yourself is probably nothing serious. It's slowly destroying your engine's internal balance, creating conditions that will lead to catastrophic failure. Vacuum leaks in naturally aspirated engines disrupt the carefully calibrated air-fuel mixture your engine requires. Your oxygen sensors detect the extra air and command the fuel injectors to compensate, but this correction isn't perfect. The result is pockets of lean combustion, too much air, not enough fuel, creating hot spots in your combustion chambers. In turbocharged or supercharged engines, the situation is even worse. Small boost leaks not only rob you of performance, but create pressure differentials that confuse your engine management system. Your ECU is making fuel delivery decisions based on false information. These lean conditions lead to detonation, the premature explosion of the air-fuel mixture before the spark plug fires. This creates shock waves that literally hammer your pistons against cylinder walls and beat your rod bearings into submission. It's the automotive equivalent of hitting your engine internals with a tiny sledgehammer thousands of times per minute. That insignificant leak is feeding bad data to your engine management system, creating combustion conditions that physically damage your engine's most expensive components. The repair for that 50-cent vacuum line you ignored could eventually become a $5,000 engine rebuild. Fix those leaks immediately. Your engine is begging you to restore its breathing to factory specification. Think that's concerning? The next killer habit happens right when you shut your engine down. Number 8. Abrupt engine shutdown. After hard driving, especially turbos, you've just finished an aggressive drive, maybe carving through mountain roads or pushing hard on the highway. You arrive at your destination, hit the ignition button, and walk away. The convenience of modern start-stop systems has made this habit almost universal. What you don't see is the thermal nightmare unfolding under your hood. When you kill the engine after high-load operation, you've just committed one of the most damaging acts possible, especially in turbocharged vehicles. Here's what happens. Your turbocharger's center housing reaches temperatures exceeding 1,000 degrees Celsius during hard driving. When you abruptly shut down, oil circulation instantly stops while that turbo is still radiating intense heat. The oil trapped in the turbo's oil passages literally cooks, breaking down molecularly and forming carbon deposits that clog oil passages and destroy turbo bearings. This process, called oil coking, creates varnish that sticks to precision surfaces, restricting oil flow and creating hot spots. Even in non-turbocharged engines, abrupt shutdown after high-load driving prevents proper heat dissipation. Thermal expansion differences cause warping in cylinder heads, and oil pressure needed to protect bearings vanishes instantly. That convenient, immediate shutdown has just condemned your turbocharger to an early death, a component that can cost upwards of $2,000 to replace, not including labor. The 15 seconds it takes to let your engine idle briefly before shutdown could save you thousands in repair bills. Next time you finish a spirited drive, Give your engine 30 seconds of idle time to stabilize temperatures and maintain oil circulation before shutdown. Your turbocharger will thank you with years of additional service. But while you're thinking about oil circulation, there's another system silently failing in millions of engines. Number 7. Overlooking the PCV, positive crankcase ventilation system. It's the forgotten component in almost every maintenance schedule, a simple valve that most drivers couldn't locate if their lives depended on it. Yet this humble PCV system is absolutely critical to your engine's long-term health. Every engine experiences blow-by, a small amount of combustion gases that slip past piston rings into the crankcase. These gases contain moisture, unburned fuel, and acidic compounds that contaminate your oil. The PCV system's job is to vent these gases back into the intake to be burned during combustion. When this system clogs, and it will, through oil sludge and carbon buildup, pressure begins to increase inside your crankcase. This pressure becomes a relentless force pushing oil past every seal and gasket. Your valve covers start to leak. Rear main seals weep oil, and worse, oil is forced past piston rings into the combustion chamber. This is when the real damage begins. Oil consumption skyrockets as it burns in the combustion chambers. Carbon deposits form on intake valves, especially in direct injection engines. Blow-by increases as ring sealing deteriorates. It's a vicious cycle of deterioration that accelerates rapidly once it begins. The tragedy is that PCV maintenance is typically inexpensive and simple. A new valve costs $20–30 and takes minutes to replace on many engines. Yet neglected, it can lead to engine repairs costing thousands. Check your service manual for PCV maintenance intervals, and if you've never replaced yours, consider doing it immediately. This often forgotten component is the key to maintaining proper crankcase pressure and preventing oil contamination. When was the last time you inspected your PCV system? The answer reveals how much you truly care about your engine's longevity. Now, let's talk about the liquid you're putting into your tank that's silently destroying your engine. Number 6. Using cheap fuel or the wrong octane. It's all the same gas anyway, right? This dangerous myth has led countless engines to early graves. The fuel you choose is quite literally the lifeblood of your combustion process, and cutting corners here is a recipe for disaster. Modern engines, especially those with direct injection and turbochargers, are extraordinarily sensitive to fuel quality. While your knock sensors can detect severe detonation, they can't protect against the insidious damage caused by low-quality fuel or incorrect octane ratings. Here's what's actually happening. Low-quality fuels contain fewer detergent additives, allowing carbon deposits to form on intake valves, fuel injectors, and combustion chambers. In direct injection engines where fuel no longer washes over intake valves, this problem is exponentially worse. These deposits restrict airflow, absorb fuel, and create hotspots that lead to pre-ignition. Using lower octane than recommended creates a particularly dangerous condition called low-speed pre-ignition (LSPI) in turbocharged engines. This phenomenon causes violent detonation that can physically break piston rings, crack pistons, and bend connecting rods. Catastrophic damage from a seemingly innocent money-saving choice. Your knock sensors can only react after detonation occurs. By then, the damage is already happening. Microscopic hammer blows to your pistons and bearings with each combustion event. Over time, these accumulate into terminal engine damage. The few dollars saved per tank using regular when premium is specified, or choosing the cheapest fuel available, will eventually cost you thousands in repairs. Follow manufacturer octane recommendations without exception, and choose top-tier fuels with proper detergent packages. Your engine was designed around specific fuel characteristics. Honor that engineering or pay the price in repair bills. The damage from poor fuel choices is bad, but what's flowing through your engine's veins might be even worse. Number 5. Ignoring cooling system maintenance. If the temperature gauge reads normal, the cooling system must be fine. This dangerous assumption ignores the complex chemistry happening inside your engine's cooling passages. Your coolant isn't just preventing overheating, it's actively fighting a chemical war against corrosion. Fresh coolant contains crucial corrosion inhibitors that prevent electrolysis between the different metals in your cooling system. As coolant ages, these inhibitors deplete, allowing the coolant to become increasingly acidic. This acidic fluid then silently attacks aluminum cylinder heads, radiator cores, and water pump impellers from the inside out. Near your cylinder liners, where coolant flows rapidly, a phenomenon called cavitation occurs. Microscopic vapor bubbles form and collapse against metal surfaces with explosive force, literally eroding your engine block from the inside. Proper corrosion inhibitors prevent this. Depleted coolant encourages it. The damage is invisible until catastrophic failure occurs. By then, your cylinder heads may be irreversibly corroded, cooling passages clogged with corrosion byproducts, and water pump impellers eaten away to nothing. What should have been a simple coolant exchange becomes a complete cooling system rebuild. Modern long-life coolants can last up to 5 years, But this doesn't mean forever. Check your coolant's condition annually, test its pH level and corrosion inhibitor content, and follow manufacturer recommendations for replacement intervals without exception. The 100 coolant flush you Vebin postponing could save you from a head gasket job or cracked cylinder head. When was the last time you changed your coolant? If you can't remember, your engine is living on borrowed time. But while coolant quality is critical, what about the quality of air entering your engine? Number 4. Neglecting air filtration. It looks a little dirty, but it can probably go another oil change. This casual dismissal of your air filter's condition is equivalent to letting someone sandblast the inside of your engine. That slightly dirty filter is failing at its core function, protecting your engine from airborne contaminants. Every cubic foot of air entering your engine contains thousands of microscopic particles, dust, pollen, industrial contaminants. A clean filter traps 99% of these. As it loads with debris, efficiency drops dramatically, allowing increasingly large particles to pass through. These abrasive particles become weapons inside your engine. They score cylinder walls, wearing away the precision crosshatch pattern needed for proper ring sealing. They contaminate your oil, turning it into an abrasive slurry that accelerates bearing wear. They damage delicate sensors like your mass airflow (MAF) sensor, causing fueling errors. The microscopic damage compounds with every mile. Cylinder compression gradually drops as rings fail to seal properly. Oil consumption increases as blow-by worsens. Your engine slowly suffocates as airflow becomes restricted, forcing your ECU to compensate with richer fuel mixtures that wash cylinder walls and contaminate oil. All of this from a filter that typically costs less than $20 and takes minutes to replace. It's perhaps the highest return on investment maintenance item on your vehicle, yet one of the most commonly neglected. Check your air filter at every oil change. Hold it up to a bright light. If you can't see light passing through clearly, it needs replacement regardless of mileage. Your engine deserves to breathe clean air. The air entering your engine is crucial, but the temperature of that engine when you start driving matters even more. Number 3. Running the engine. Cold under load. The morning routine is familiar. Start the car, immediately put it in gear, and drive off while adjusting the climate control. Modern engines warm up quickly, and who has time to wait? This seemingly efficient habit is actually devastating to your engine's longevity. Cold oil is thick oil. At startup, especially in cold weather, your engine oil can be the consistency of molasses. In this state, it struggles to form the critical hydrodynamic oil films that separate metal surfaces under load. The result is metal-to-metal contact exactly when your engine is most vulnerable. The first 60 seconds after cold startup are when over 60% of all engine wear occurs. During this period, critical components like camshaft lobes, valve lifters, rod bearings, and turbocharger shafts are operating with minimal oil protection. Every cold start where you immediately apply load accelerates wear exponentially. Turbocharged engines suffer the most from this habit. Cold oil can't properly lubricate turbo bearings spinning at over 100,000 RPM. The microscopically precise clearances in these assemblies require proper oil temperature and pressure to prevent premature failure. The solution is simple. After cold startup, allow 30-60 seconds of idle time before driving. This isn't about warming the entire engine. It's about allowing oil pressure to fully establish and initial oil circulation to begin. Then, drive gently until operating temperature is reached, avoiding high RPM and heavy load. This one habit alone can add years to your engine's lifespan with zero financial investment. The minute of patience will save you thousands in repair costs. Speaking of oil, let's talk about the most commonly misunderstood aspect of engine lubrication. Number 2. Using the wrong oil. Viscosity. Oil is oil, and thicker is better for protection. This dangerous misconception leads countless engines to early graves. Modern engines are precision machines designed around specific oil viscosities, and deviating from these specifications creates a cascade of failures. Oil viscosity, those numbers like 5W30 or OW20, isn't just a recommendation, it's a critical engineering specification. Modern engines have incredibly tight clearances, complex variable valve timing systems, and oil pressure actuated components that all depend on very specific oil flow characteristics. Using too thick an oil creates excessive drag, reduces fuel economy, and actually starves critical components of lubrication. Those complex VVT systems rely on precise oil pressure and flow to function properly. Turbocharger bearings running at over 100,000 RPM require specific oil viscosity for proper cooling and lubrication. Using 10W40 when 0W20 is specified doesn't provide extra protection. It creates oil starvation in these precision components. Conversely, using oil too thin for your application fails to maintain proper film strength under high loads, allowing metal-to-metal contact between critical components. The microscopic clearances in modern engines leave zero room for error in oil film maintenance. The engineers who designed your engine spent thousands of hours determining the optimal oil viscosity for your specific application. They tested extreme conditions from Arctic cold to Death Valley heat. The viscosity in your owner's manual isn't a suggestion. It's the result of exhaustive testing and precision engineering. Follow the manufacturer's viscosity recommendation exactly. Your engine's longevity depends on it. Now we've reached the most critical error drivers make, one that undoes all other maintenance efforts. Number 1. Ignoring oil change intervals. My synthetic oil can easily go 15,000 miles between changes. This dangerous myth has destroyed more engines than perhaps any other maintenance misconception. Even the most advanced synthetic oils have limitations that the marketing departments don't want you to understand. Oil doesn't just lubricate, it's a complex chemical package containing detergents, anti-wear additives, viscosity improvers, friction modifiers, and corrosion inhibitors. These additives don't last forever. They deplete through normal engine operation, regardless of how premium the base oil might be. As you drive, combustion byproducts contaminate your oil. Acids form from blow-by gases, moisture from short trips that never fully boil off creates conditions for sludge formation. Microscopic metal particles from normal wear remain suspended in the oil. The longer you extend your oil change interval, the more these contaminants concentrate, overwhelming the oil's additive package. The result is accelerated wear across all engine components. Bearing surfaces develop micro-pitting that progresses to full failure. Camshaft lobes and lifters develop flat spots. Piston rings lose their free tension as deposits form in ringlands. Oil passages narrow as sludge accumulates, restricting flow to critical components. The most insidious part? This damage is invisible until it's catastrophic. By the time your oil pressure light illuminates or your engine develops an audible knock, the damage is terminal. The few $100s saved by extending oil changes transforms into a multi-thousand-dollar engine replacement. Follow manufacturer oil change intervals as the absolute maximum, not a target to exceed. For severe service, short trips, extreme temperatures, dusty conditions, or performance driving, reduce those intervals by 30–50%. It's the cheapest insurance you can buy for your engine. Your engine is literally crying out for fresh oil. Are you listening? Listen up, because this is about to get real. Everything I've shared today flies in the face of what the auto industry wants you to believe. They've built business models around your ignorance and willingness to accept good enough maintenance. If you've recognized even one of your own habits in this video, your engine is already showing signs of accelerated wear. The question is, will you continue down this path or will you break the cycle? But there's something even more shocking I haven't told you yet. Something that explains why dealerships and repair shops actually want you to follow these destructive habits. Before I reveal that final truth, one that will change how you think about vehicle ownership forever, I need to know you're serious about engine protection. Hit that subscribe button and smash the like if you're ready for the ultimate insider knowledge that the industry desperately wants to suppress. Which of these deadly habits are you guilty of? Drop a comment below. Your honest answer might help save someone else's engine from an early grave. The discussion this creates will expose just how deep this problem really goes. Now, are you ready for the truth no mechanic wants you to know? What if I told you modern engines are designed to fail just after warranty? The engineering compromises, the maintenance schedules, even the oil specifications, all calculated for planned obsolescence. The evidence is overwhelming and the implications are staggering. By implementing the protection strategies I've shared today, you're not just saving money, you're fighting back against a system designed to separate you from your hard-earned cash through preventable failures. Your engine deserves better. You deserve better. And now you know exactly how to give it the protection it needs. Thank you for watching. What engine protection topics do you want me to expose next? Let me know in the comments and subscribe to make sure you don't miss the next video that could save you thousands in repair bills. Until next time, drive smart and keep your engine alive.